Hello everyone, welcome to Beginner's Guide to TypeScript. So now let's get started. Firstly, I'm going to give you a brief introduction about the TypeScript. So TypeScript is a superset of JavaScript. TypeScript builds on top of JavaScript. First, you write the TypeScript code, then you compile the TypeScript code into plain JavaScript code using a TypeScript compiler. Once you have the plain JavaScript code, you can deploy it to any environment that the JavaScript runs. TypeScript file use the .ts extension rather than the .js extension of JavaScript files. TypeScript uses the JavaScript syntaxes and adds additional syntaxes for supporting types. So basically, what the code does, first you are going to write something in TypeScript, and then it will get sent to the TypeScript compiler. Then the compiler will turn that code into a JavaScript code, and then JavaScript code gets executed. Now, why TypeScript? It introduces optional types to JavaScript, implement planned features of JavaScript. TypeScript improves your productivity while helping avoiding bugs. TypeScript brings the future JavaScript to today. So, understanding the dynamic type in JavaScript. JavaScript is dynamically typed, unlike statically typed language such as Java or C. Values have types instead of variables. For example, here we are declaring a variable, and in this variable, it can be a string or it can be a number. The type of the box variable changes based on the value assigned to it. So to find the type of the box variable at runtime, use the type of operator. In the runtime, if you use the type of uh, if you use the type of, then it is going to show you undefined at that time. If you write hello inside quotation, then it is a string, and if it is a number, then it's a number. So in this example, the first statement defines the variable without assigning a value. Its type is undefined, then string, then the number. As you can see, as soon as the value is assigned, the type of the variable changes. And you don't need to explicitly tell JavaScript the type. JavaScript will automatically infer the type from the value. Dynamic types offer flexibility, however, they also lead to problems. So let's see what kind of problem we are going to have. Suppose that you have a function that returns a user object on an ID. This is the function. It is going to return ID, name with ID, and then age. And in the parameter, it is going to take an ID as an argument. Then the following uses the getUser function to retrieve the user with ID1 and show its data. Now, if you want to, it's not going to be product, it will be user. Now, if you use the getUser and then console log it, then it is going to show you undefined. Why is that? Is because if you look at this object, you can see here it is in lowercase, this name, but here I am writing this in uppercase, so it is not finding it because JavaScript is case sensitive. So it's not going to find anything in the user object. It is going to go there and see that there is nothing, so it is giving me an undefined. However, you can only know it until you run the script, and that's an issue because you would want to find things while you develop. Now, TypeScript solves this problem by dynamic typing. So first, we are going to create an interface. What is an interface? Interface is basically a shape. It is telling that whatever data I'm going to have, it should follow this. Now, when you try to call something or write something, then it is going to give you an error. If you just try to run this, then underneath this, it will show you an error and say that, okay, this type of thing does not exist because we are going to use this interface or the shape here by by uh, writing a colon and then the interface. So it is going to say whatever the value that you are going to get in return should match this. And if you want to find something a value like this, it's not going to, it will show you an error at the runtime. So when you reference a property that doesn't exist, the code editor will inform you immediately. In summary, you can say that TypeScript enhances JavaScript development by providing static typing, improved code readability, better tooling support, and compatibility with modern JavaScript features, ultimately leading to more robust and maintainable code bases. So now that we know that what TypeScript is and why we need that, so let's get started with the installation process. So first thing, you need to have Node installed in your computer. If you don't have it, then you can just follow this link and it is going to take you to the download section. This link will take you here. Here you can download the version that you want to download, your operating system, and then either 62-bit or 32-bit. You can download and just install it. And after you have done that, you have to make sure that it has been installed in your computer. And to do that, you open up your terminal and then write node dash dash v. Node dash v is not going to be dash dash. I'm going to fix it right now. Node dash v. So it is going to give you the version that you are currently using. And then you need to install nvm. NVM means Node Version Manager. You may have a lot of Node versions installed in your system, and you'd want to choose them, or maybe you want to see them. So for doing that, you can download the NVM for Windows download link, and you can follow this link. It will take you to this page, and here you can download this nvm setup.exe, download it, and then it is very easy to install. After you have done that, you need to check that either the nvm has been installed or not. So write nvm dash dash v. It is going to show you the version number, and you can be certain that okay, nvm has been installed. Now if you want to check how many node version you have on your computer, you can just write nvm list, and it will show you the node version you're currently using and the node version installed in your pc. And then you can choose which version you want to use. So you can just write nvm use, then the version number, and it will just run that version of node. And then you need to install TypeScript. So npm install g TypeScript to install it globally. Let's install it. And then um as a dep dependency, before doing that, install this npm init y. Now package JSON has been installed, and I need to install the um, TypeScript here. So I'm going to install as a dev dependency. So install TypeScript save dev. Now if I look at the dev dependency, I can see that the TypeScript has been installed. Then I need to install node mod because From TypeScript file, it is going to change to JavaScript file. And every time it changes, I would want to show the outcome immediately. So I don't need to run extra commands there. To solve this, I will install nodemon and just npm id nodemon. And nodemon has been installed here. Now I'm going to take a file and I'm going to write index.ts. This is going to this created the TypeScript file because ts.ts is the extension. And if I write tsc index.ts, you can see a JavaScript file has been created. So the compiler has created a JavaScript file. Now, if I write something, let's just say, let um, hello, and I say hello world, and go to here, I can see nothing. But if I just write tsc index.ts, I will see that this JavaScript file has been created, has changed. And if I want to see that in my console, I can just write nodemon, then index.js here. Nodemon started. I need to console that as well. Console log hello. And then again, let me open up another terminal, split terminal, PowerShell, and then tsc index.ts. So I can see that my JavaScript file has changed and nodemon is showing the console version hello world. Now, uh, every time I don't want to write the tsc or compile it, so I'm going to write tsc index.ts, and if I write dash then w, then it is going to watch it. So now it is watching. Now if I write something else, hello world, uh, what's up? Uh, uh, what is going on? If I write that, you can see in my terminal it has automatically changed, and index.js it has automatically changed. So we have just started. This is what you need to get started with TypeScript tutorial. And in the next chapter, we are going to learn about some basic types. In this lesson, we are going to learn about the basics of TypeScript. So what is a type in TypeScript? In TypeScript, a type is a convenient way to refer to a different properties and function that a value has. A value is anything that you can assign to a variable, such as a number, a string, an array, an object, and a function. So let's have a look here. If I write here hello world, when you look at this value, you can say that this is a string, and this value has properties and methods that a string has. For example, this hello world value has a property called length that returns the number of characters. It also has many methods like match, index of, to local uppercase. So if you look at the value hello and describe it by listing the properties and method, it would be inconvenient. A shorter way to refer to a value to assign it is a type. In this example, you can say that hello is a string. Then you know that you can use the properties and methods of a string that the value hello has. So, in conclusion, we can say that in TypeScript, a type is a label. It's a label that describes the different properties and methods that a value has, and every value has a type. Now, let's talk about types in TypeScript. TypeScript inherits the built-in types from of JavaScript. TypeScript types are categorized into two types: primitive types and object types. The following illustrates the primitive types in TypeScript. String, it represents text data. Number represents numeric values. Boolean has true and false values. Null, it has one value, that is null. Undefined has one value, that is undefined. It is a default value of an uninitialized variable. Symbol, this represents a unique constant value. Object types, object types are functions, arrays, classes. So later you'll learn about to create custom object types. So what are the purpose of types in TypeScript? There are two main purpose of types in TypeScript. First, types are used by TypeScript compiler to analyze your code for errors. And second, types allow you to understand what values are associated with variable. So if I go here and write, let let me first decrease the size. Let word is going to be hello world and console log word. If I go to the compiler, I can see that it is showing hello world. This should be enough. It is showing hello world. Now let's give it a type, and this is how you give type: string. I'm telling that this word, whatever the value this variable has, it has to be string. It cannot be something else. Now, if I give it a number, now we can see that it is throwing me an error. It is saying that type number is not assignable to type string. So I can easily, while coding, can fix my errors. I can see that, okay, this is not a this is not a this type of number is not assignable to type string. Now, if I just put it in string, then the error is gone. Now let's learn about the type annotation in TypeScript. So what is type annotation in TypeScript? TypeScript uses type annotation to explicitly specify types for identifiers such as variables, function, objects, etc. TypeScript uses the syntax a colon, then the type after an identifier as the type annotation, which type can be any valid type. So type annotations in variables and constant. Let variable name, then the type, let variable name, type value, and this type value. So let's see that in code. First, let me TSC, then type annotation. I'm doing it here, TSC, type annotation, TS, and then W. So it is going to keep on watching it. And here I'm going to change node mon, then type annotation.js. Okay, now I can see what is happening. Okay, so to show how we can annotate a variable, I can say that let my word is going to be a type of a string, and it is going to be my first TS word. And I'm going to console log it, my word, node one. So it is showing that my first TS word. If I do that for constant, my const word, not word, let's just say number, and it is going to give me a number, and I'm say it is going to be equal to 23, and console log my const number. So it is giving me 23. Now let's see how we can annotate in arrays. So let array name and then type followed by a bracket. Okay. So it is going to be array. I will add let my array is going to be um, first take array 1, 2, 3, 4, 5, and then console log my array. If I write string, then it is throwing me an error. Why? Type number is not assignable to type string. So it is going to be a array of numbers. Now there is no error. Type annotation in object. So object, then object. Okay. So we are going to learn this later. Now let's just say object. I'm going to write type my uh, object type, and then let's just say ID, and it is going to be string. And then I'm going to write an object const objectify, then just write ID and give a number of 23. Now if I object 2, this is the type here. I'm using this type. Now it is throwing me an error. Why? Type number is not assignable to type string. So if I change it to number, then there is no error. So this is how we can write types for objects, and then function argument and return type. Then let greeting this. So let's write a function, and then you can see here function. Function, let's just say we are going to write let greeting, and then it is going to take a parameter name. It will have a string, and whatever it returns, it is going to be an also string. Now I'm going to take the function, write the function greeting, and then function, then name is going to be string, then return. So this is how I can assign. So for arrow function, I can assign them like this, and for regular function, I can assign the parameter like this. Now, whatever the thing that I'm hoping to get, The return value, this is also I'm assigning here. And if I want to assign the return value here, I can just write string. So this will also give me, so this is how we can annotate and use type in functions. Now let's start with the basic types. First, we will start with the number type. Number types, all numbers in TypeScript are either floating point values or big integers. The floating point numbers have the type number, while the big integers get the type big int. So let's have a look at the floating point numbers. Number, then I'm going to write let this number is going to be 13. Console log this number, and I'm going to give it a type of number. So it is showing me the base number type. And now if I want to see the big int, so what is the big int? Big integers. The big integers represent the whole numbers larger than 253, 2 to the power 53 minus 1. So a big integer literal has the n characters at the end of the integer. So the big integer, let big, is going to be let's just say 9007199254709991, and then add. Big ints literals are not okay. If I write here, it is not so targeting lower than yes 2020. Right now we are using, I think, yes 2016. Yes 2016. So this is why it is throwing an error, are not available when targeting lower than. So but the idea is that if you want to use the, if you are using big int, then use the type big int like this, then comment them out. Okay, now let's have a look at the string types. Like JavaScript, TypeScript uses the double quotes or single quote to surround the string literals, and for string we can just write string and then let this is my string and write this is my TS string. And if I console log it, this is my TS string, and I can just give it a type of string. So for any string, we are going to use the type string. Another type is Boolean type. The TypeScript Boolean type has two values, true and false. The Boolean type is one of the most primitive values in TypeScript. So let's have a look at Boolean. Let my Boolean and then write true. So it is giving me true, and I can use the type Boolean. And now if I give it a number, it is throwing me an error saying that the number is not assignable to type Boolean. But if I write false, then everything is fine. Object type. The TypeScript object type represent all values that are not in primitive types. So object type, and let me comment them out. Let's just say we describe a variable employee and say that it is an object. Now, if you write employee and then in that you say ID 1, name John Cena, age 25, and title none, and console log employee. So what will we see? I'm seeing the title here, the object employee object here. Now instead of object, if I just give a number, then it is throwing me an error. It says that the number is not assignable to type object. So it has to be an object. There is another way we can write this. So let's just say let employee mm, let me remove this and then employee and then ID is going to be a number, name is going to be a string, age is going to be a number, and then title is going to be a string. And now it will equal to ID 23, name John Cena, and then age 23, then title is going to be string, no title. So we can see that we can check our object here. If I, instead of a number, if I just write a string, let's just say none, string 23, then it is throwing me an error. It says the type string is not assignable to any number. So I'll change it to number 23. Now, there is a thing we need to remember, object versus object. So TypeScript has another type called object with the letter O in uppercase. It is important to understand the difference between them. The object type represents all non-primitive values, while the object type describes the functionality of all objects. For example, the big O object type has the toString and value of methods that can be accessible by any object. And another thing to remember, the empty type. TypeScript has another type called empty type denoted by curly braces empty, which is quite similar to the object type. The empty type describes an object that has no property on its own. So it has no property on its own. If you try to access the property of such object, TypeScript will issue a compile time error. So let's see that in action. I'll just comment them and say let can see is going to be an empty object. Now, if I try to put any Control J, let's just say if I try to include any property to it, vacancy dot first name John. So what does it it is throwing me an error and it is saying that property first name does not exist on type empty. So if you keep it empty string and try to cannot set properties or undefined first name. So you cannot, but instead if you just say first name and string, Then it is still showing the error. Oh, it is vacancy is used. You're using it. So that is why it is showing that. So bottom line is y- the empty object that has no property on its own. So it does not have any property. If you try to add any property uh, on that object, TypeScript will issue a compile time error. Let's learn about array type. A TypeScript array is an ordered list of data. So we will follow this type of schema to put type on arrays. Let's first declare an array type. I'm going to declare an array. I'm going to say let my array 1 and then put some numbers in it. And I'm going to console log that my array. Now I can see that I am seeing my arrays. Now I did not put any type on it. And what kind of type are this thing going to be? And if I can see that, I see that these are numbers. So I'm going to say these are going to be number. But yes, these are numbers, but if I look here, I can see that to declare an array, first I'm going to say the name of the type and then array sign. So I'm going to say that, okay, it is going to be whatever inside that array is going to be number, but these are going to be in an array. Now TypeScript is not throwing me any error. So if I put any strings in it, string, I can see that TypeScript is throwing me an error. Type string is not assignable to type number. So I'll change it to 1. Now if I put a string in it, string, then I can see that the number is not assignable to type string. So all these have to be string. Name. Now TypeScript is not throwing me any error. Now we know that storing values of mixed type. In TypeScript, an array is a list of values. An array can store a mixed type of values. So I can store a lot of things here. I can store, let's just say a string. I can store number. I can store boolean. So, but how do I do that? Here it is throwing me errors saying that it cannot be boolean, then type, anything. It cannot be that type. So how do I solve this? To solve it, we are going to say the type in bracket. We are going to say the type is going to be either string, either number, or either boolean, and then the arrow sign. It is going to be true or false, not boolean. Now it is not showing me any error. If I remove the boolean part, now it is showing me an error. If I remove the number part, now it is showing me an error. So to solve this, I can say number and then I can say boolean. And if I remove the array sign, then it is showing me an error. The type is not assignable to type this. So if I put an array sign, this solves the issue. Let's learn about tuple values. A tuple works like an array with some additional considerations. The number of elements in the tuple is fixed, and the type of elements are known and need not be the same. In TypeScript, tuples are similar to arrays but have a fixed number of elements, and each element may be of a different type. Once declared, the types of element within the tuple cannot be changed. Now, let's code them up. Let's say tuple. Now I'm going to declare a tuple. So first thing, declare a tuple, and it is going to be let person And I'm going to say the first thing is going to be string, the first element, second element is going to be number, and the third element is going to be a boolean. And now initialize the tuple. Now the person, I can say, is going to be John, then 30, then true. Here I need to put a colon. Now 30, true. But instead of John, if I put 30 here, what it is showing me? It is showing me that number is not assignable to type string. So whatever the person is, we have set the types in the beginning and then we can initialize it. So I can say John here. I can see that the number of elements in the tuple is fixed. The type of elements are known and need not be the same. So number of elements here are fixed. If I put another number 40, then it is throwing me an error. Source has 4 elements, but the target allows only 3. So we can only have the number of elements must match the tuple values. Boolean, and here I can, if I write number here again, now I can see that it is not throwing me any error. Here there are 4 types and here there are 4 values. And if I want to access them, I can just do them person, and then if I put 3, then it is giving me 40. Nothing is changing. It is behaving same like an array. And you can also destructure the tuples to variables. So let's just say, let's do another, let's do it in another way. You can also use destructuring to assign tuple values to variables. And now I can use let, I'm going to say name, age, then is admin, and it is going to be person. Now if I, where is it? Now it is name to cannot declare block scope variable name. So here I can say just name to, then it can find the name person. So we are going to bring it here, the person, and uncomment this. And then we are going to bring this here and uncomment this. So we have our type, we have our person, and now we would want to destructure it. So if I console log name2, I can see that the name John is showing. If I John Cena, then it is showing me John Cena. If I put age and is admin, then it is showing me the name is name, age is age, and is admin is true. Now here is another number. Now if I put that salary and then put 40 something and put salary here, it will also show me the salary. So the order is very crucial here. If you try to access an element outside the tuples length, the TypeScript will give you an error, and you need to be careful about the order. Here name will show the first thing, first element, age, second element, then is admin, third element, and salary, fourth element. So ordering matters here. Now let's learn about enum. Enum types. An enum is a group of named constant values. Enum stands for enumerated type. In TypeScript, an enum is a data type that allows you to define a set of name constant. Enums are useful when you have a fixed set of related values that you want to represent with more descriptive names rather than using raw numbers or strings. So let's have a look at them in code. Enum. Now, to declare an enum, first we need to write enum keyword and then the name. Let's just say in this case direction, and it is going to be up, down, left, or right. Now I will using the enum. Now I can say let player direction, and the type is going to be direction, this direction. Type is going to be this direction. Now if I equal it and write direction, and if I put dot here, let's say, now you can see that it is showing me the values here, up, down, left, right. It is showing me the values here. So the player direction is going to be the down direction. Let's console log it and see what it shows me. Player direction. So it is showing me 1 because the enum starts from the 0 position. So 0 is up, down is 1, 3, 4. If I just go and press dot, then right. So it helps us because we don't have to write anything else. Uh, there is very little chance of making mistake. Let's just say if I wanted to write left, left, if I make a spelling mistake here, lefts, then it might cause any trouble. But if I use the enum, then there is very little chance of making mistakes, and 50 developers can do the same thing without any issue. Now we can also assign specific values to the enum members. Let's have a look at that. Now I'm going to take another enum and I'm going to say it color. And here the red is going to be value is going to be not color. Let's just say salary. John will have a salary of 40,000. Then Orton will salary have a 50,000. Then Edge will salary have a 60,000. Then Undertaker will have a salary of 70,000. So this is the enum value. Now I'm going to say let wrestler salary, and it is going to be type salary. And now if I equal it and say salary dot, then I can see that whose salary I want to see. I want to see Undertaker's salary. So if I console log them, let's see what it shows me. Your wrestler salary. Now it is showing me the salary 70,000. So I can assign values to my enums as well. Now the question is, when should you use enums? You should use an enum when you have a small set of fixed values that are closely related, and these values are known at compile time. For example, for example, you can use enum for approval status. Let's write enum, then then approval status, and then I can say draft. This is not going to be equal sign. This will be just a colon. Oh, no. In Enum, there will be nothing. Then submitted, then approve, then status going to be rejected. Rejected. Now I can use this approval status Enum like const request, then ID is going to be 1. Then status, I can say that approval status dot. Now, what is the status? What is the status here? I can easily say that. I can say that approval status is approved, and then the description is going to be please approve request. And here there will be a comma. And now I can use it. If request dot status equals approval status dot approved. See, I did not try to manually type anything. I could have written approved and something, but it would have made some grammatical mistakes or syntax error and something like that. But if I just write approval status dot approved, then the both are the same. The both can be the same. Now, if this happens, then console log send an email to the applicant. See, here it is showing that send an email to the applicant. And now if I change the status from approved to draft, it is showing me nothing. If I just console log and not approved, then it is showing me not approved. If I change from draft to approved, then it is showing me send an email to the applicant. Any type. In JavaScript, the any type is a special data type that represents values of any data type. Variable declared with the any type can hold values of any type, and TypeScript will not perform type checking on these variables. Sometimes you may need to store a value in a variable, but you don't know its type at the time of writing the program. And the unknown value may come from a third-party API or user input. So let's have a look at some of the examples of any type. Here I'm going to write any types. First, I'm going to declare a variable. Let any value, it is any value, it is going to be of type any. Now, this any value can hold value of any type. If I write any value equal to 5, equal 5, and then console log 5, console log any value, I can see that it is giving me 5 and it is not throwing me any error. I can also change the any value to a string, hello world, and I can console log that as well. It is showing me 5 and also it is showing me hello world, and I can change it to boolean as well, true, and then any value. So it is showing me 5 hello world true, and also I can use it in any object as well, any value, and then declare an object names, and then I can say John, then age, I can say 30. Let's console log any value. So it is showing me a number, a string, a boolean, and also an object. Now, while using the any type can be convenient, it can also lead to less type safety in your code because TypeScript does not perform type checking on variables declared with the any type. So it is often recommended to avoid using any whenever possible and instead of use more specific types to take advantage of TypeScript's static type checking capabilities. However, there are some scenarios while using any may be necessary, such as when interfacing with existing JavaScript libraries that do not have the type definitions, and when you don't know what API, what data your API is going to throw at you. So that's when you can use any type, but it is not usually recommended. The never type. In TypeScript, the never type represents the type of values that never occur. This type is typically used to indicate that a function will not return normally. For example, it always throws an error or enters an infinite loop or that a variable cannot have any value at all. For example, it's never initialized or always reassigned. The never type is useful for catching logic errors and ensuring type safety in your TypeScript code. It's often used in conjunction with advanced type checking and control flow analysis to make code more robust and maintainable. So let's have a look at that in action. Never type. And I'm going to say a function that returning never. So a function that never returns normally typically because it throws an error or enters an infinite loop. For example, throw error and then message is going to be a string and it is going to be never and then throw new error message. So in this example, the function throw error always throws an error. So its return type is never because it is going to throw an error. It is not returning anything. Return nothing. It is not returning. So it is going to always throw an error. So we are going to say that the return type is never. Then a function with unreachable end. So a function with a condition block for TypeScript can determine that certain branches never return. Now the function infinite loop and it is going to return never while true console log this function never ends. Now here is the function infinite loop. It enters an infinite loop. So TypeScript infers that the return type is never because it is going to go on an infinite loop. And then type guard with exhaustive checks, a typeguard function that ensures exhaustive checking of all possible types. For example, function assert never x is going to be never, and then return type is going to be never. So throw new error is going to be unexpected object plus x. Now this function takes a parameter of type never. It takes a parameter never, and since there are no possible values for never, this function should never be called with any argument. So this function should never be called. If it is, That means if it throws an error, then it means that something unexpected has happened. So we can use this to catch logic errors and ensure type safety in my TypeScript code. Union type. A union type in TypeScript allows a variable to have more than one type. You can combine types using the OR operator to create a union type. This means that a variable declared with a union type can hold values of any of these specific types. So let's have a look at that in code. Union type. So first I'm going to define a union type, and then I'm going to say phone number. It is going to be either string or it is going to be either a number. Now assign values to the variable. Now I can say that the phone number, it can equal to a string 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I console log it, phone number, I can see that it is showing me the phone number, no arrow thrown. Now I can change the variable as well. If I change it to a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it is also showing me a number. Now if I write a boolean here, phone number, let's just say it is a true, then it is throwing me an error. The type boolean is assignable to type string or number. So it can be either string or it can be either a number. Now I can use this type guard to narrow down the type within the union. So let's use the type guard if type of phone number equals a string, then I can console log phone number dot length. Why it is getting a never? So it is creating an issue. The length does not exist on never. Maybe I have written never here. So the value never. Maybe because I've written the never before, that's why it is causing an issue. So I'm going to use another example for union type. And I'm going to say a union type is going to be type, shape is going to be circle or square. Then I'm going to define an interface for the circle. Interface circle, it is going to be kind is going to be circle, and then radius is going to be a number. And then I'm going to say interface for the square, interface as square, and then I'm going to say kind is going to be square, and side length gth is going to be number. Now I'm going to write a function. Function calculate area. So it is going to be shape. Shape will be of type shape. This shape will be of type shape, and it is going to return me a number. Now, what I'm doing here, I'm using the union type here to describe the interface for these two, circle and square. Now, if I say that shape dot kind dot shape dot kind is equal to circle. See why shape dot kind equal to circle. So I'm getting this from here. It is going to check the shape, and from shape it is going to check the kind, and from here I'm going to get the circle. If it is circle, then return math dot pi multiplied by shape dot radius, then exponent 2. Else return shape dot. See, it is also giving me the two options only, kind and side length, because it knows if it is not circle, then it must be side length. Because if it is a circle, then it should be the radius, and if it is not, then it is going to be side length. So TypeScript is inferring that. Then side length exponent 2. Now let's test with the circle. It is going to be, let's circle kind circle and then radius 5. Then I'm going to console log calculate area circle circle. So what I'm doing here, I am declaring an object, and the object is going to follow this pattern circle, and the kind is going to be circle, and the radius is going to be 5. And then I have called the calculate area function and sent the circle as the parameter, as the argument. Now if I console log it, I can see that I'm getting my value here. If I change radius to 10, the value should change. The value has changed. And I can also test this for square as well. Test for square. It is going to be square. The kind is going to be square. Now it is throwing me an error, says that it cannot be this. It has to be side length. Side length. Now if I send the square, now I'm getting the square, because 10 multiplied by 10 is going to be 100. If I put 20, then it should give me 400. It is giving me 400. So this is how you can use the union type. Now let's learn about type aliases. Type aliases in TypeScript allows you to create a new name for type. This can be useful to simply complex type definition or to make types more descriptive. So let's see that in action. First, let me, uh, okay, this should be better. Now I'm going to say that first I'm going to define a type alias for a complex data structure. I'm going to say type is going to be point, and then it's going to be x is going to be number, and y it is going to be a number. And then we can use the type alias. Point, it is going to be the type alias point, and x is going to be 10, y is going to be 20. Point. So by the type alias definition, it says that allows you to create a new name for a type. So here I have created a new name for this type. So this is called a type aliases. We can use TypeScript alias in union type as well. So let's look at that. We can say type result is going to be success or error. Success or error. Why is that? Cannot find name success. Okay. Now interface is going to be success, and then success is going to be true, data is going to be string, and then interface is going to be error, then success is going to be false, and data will also be an string. Now I have taken two types and declared and set them in a type alias. Now let's use them. I can say success result, and the type is going to be result here, not the success. Type is going to be result here, and then success is going to be true, data is going to be. Here I made a spelling mistake. This success is going to be this, so it can be true. Nothing is going to cause an issue. And then I can also write a error message, and I'm going to write let error result. It is going to be a result, and then this object. I can say it false, operation failed. So here it is giving me a error. It is saying that the error result is missing the following properties. In the error, it is expecting a name and message. I don't know where it is coming from, but let's give it name is going to be string, then message is going to be a string also. So I'm going to say name, stupid name, and message is going to be A, B, C, D. Now the error is gone. Oh, string. Now the error is gone. Now if I console log them, success result, and then error result, I can see that all my success result and error results. Now, first, uh, these type aliases, they are actually make my code more readable and maintainable by giving meaningful names to complex types or a combination of types. They allow me to reuse type definition throughout my code base. So you can see that By using this type alias, the result, I can just give one type to result, and it is checking both these types by using this result type. So I don't have to write success message, I don't have to write success for success, I don't have to write error for error. I can just write the result for both of these because they are basically result and it is taking care of both of them. So this is how we can use the type alias for complex data structures. Now, string literal types. String literal types in TypeScript allows you to specify that a string variable should only have a particular exact value. This adds precision to your type definition and helps prevent unintended values from being assigned to a variable. So let's see that in code. Let's just say I want a type, and for role, role is going to be employee, it is going to be manager, it is going to be admin, or it is going to be super admin. Now, if I say role, this role is going to be in capital. If I say role and give it a type of role, and now whenever I want to write something, it is giving me options that choose from these options. If I write something else, right, uh, super duper admin, it is throwing me an error. It is saying that the type super duper admin is not assignable to type role. So I can just, I have to just use any of it here. So these string literal types are particularly useful when you want to limit the possible values of a string variable to a specific set of known values. This ensures type safety and provides better code documentation and readability. Now let's learn about TypeScript functions. TypeScript functions are the building blocks of readable, maintainable, and reusable code. Like JavaScript, you use the function keyword to declare a function in TypeScript. And in this lesson, we are going to learn these things: parameter types, return type, optional parameter, default parameter, rest parameter, and function overload. First, let's learn about the um, parameter types. You can specify the types of function parameter to enforce the type safety. So here is an example function. Function, I'm going to say it is going to be grid. Name is going to be the type of string, and the console log is going to be hello name. Now, if I console log it, let me first set up tsc. Now I need to call that function. If I call this function, so it is telling me that hello undefined because I have not given it any parameter argument, and the argument is going to be John Cena, and it is saying that hello John Cena. Now, instead of string, if I put send 23 as an argument, it is giving me an error. Argument of type number is not assignable to parameter of type string. So this is how we can use parameter types. Now let's focus on the return type. Now we can specify the return type of a function to ensure that the function returns the expected type of the value. Here, you are not returning anything. But if I say that I'm returning a string and it is showing me an error, let's see what. A function whose declared type is neither undefined, void, or any must return a value. Because I'm not returning anything, instead of console log, if I return hello, then the problem is gone and I'm going to give it a John Cena. Now, as I'm not console logging it, so I'm not seeing it. If I console log this, then I'm seeing hello John Cena. So I can return it. And if I don't want to return anything, if I want to return a number, then I can return a number. Now it is returning me 23. I can return an object. I can return an interface, whatever that is. I just have to write this. And if I'm not returning anything, I can just don't write anything or I can just write void. So console log, this is my name, and it is returning. Now it is returning my name is John Cena. So void means I'm not expecting to return anything. Now let's talk about the optional parameters. Suppose I want to make the parameters optional. And how do I do that? So I can just write name, string, and then I'm going to take another parameter. I'm going to say it greeting, and it is going to be string. And the return type, let's not put anything right now. Let's just put return type is going to be a string. So if I return my name and this is the greeting, then console log put this here. So I can see that it is throwing me an error. It is saying that expected two arguments but got one. Now I want to make this argument parameter optional. How do I do that? I just put a question mark here. Now it is not showing me any error. Now it is showing me that this is my name Johnson and this is greeting undefined because I have not put anything in that greeting. But I want to put something in the greeting. Even if I am not writing anything, I want to put something in the greeting, a default value, a default parameter. And how do I do that? I'm writing it here and then I'm going to say it. It is a optional parameter and it is going to be good morning. Hello from me. Parameter cannot have a question mark and an initializer. So now, even if I don't put anything here, it is saying that, hello, this is my name is Johnson and this is the greeting from me. So I did not put any parameter, I did not give any argument. Even if I do good morning, then it is showing that this is a greeting good morning. It is showing good morning. But if I don't put anything, then it's okay as well. Then it is going to show me uh, the default greeting. Hello from that. Now here I know how many parameters are going to be there. But suppose I don't know how many arguments my function is going to throw at me. Let's just say I am going to sum something. I'm going to add something and I'm going to let's keep it as parameter. Let's just say I'm going to add something and I'm throwing a lot of numbers, one, two, three, 4, 5, and a lot of numbers. Now, is it possible to write argument for all of them? No, it's not. So I'm going to take a function and name it sum, and I'm going to give it numbers. I'll receive numbers, and the type is going to be number. I'll return a number, and then return numbers dot reduce. It will go to values number, then it is going to be total plus number, and the initial value is going to be 0. So it is throwing a lot of errors. Expected one argument but got 5. I'm giving it a lot of arguments. So let's console log it first. Console log and put it here. My app has also crashed and reduce method, they cannot use it. So to solve this issue, I can just use the res parameter. I can put 3 dots in front of arguments and say that whatever the arguments I'm getting, destructure them. They are going to be in array format. The arguments that I'm receiving, they are going to be in array format. So destructure them, uh, identify them, and as I'm receiving them in an array format, put array here. It is going to be num, not num. Put array here, put array here, array sign here. That means I'm receiving them in an array. Whatever I'm receiving, destructure them, and I'm going to get a return value of number. And then as I'm receiving array, I can just use the array.prototype.reduce method and add all of them. Now, if I add 1, 2, 3, 4, I can just get the value 1 and 2 is 3, 3 plus 3, 6, 6 plus 4 equals 0. So this is how we can use the res parameter. Now let's talk about function overloading. So in TypeScript, function overloading allows us to establish the relationship between the parameter types and the result types of a function. So let's write some simple functions. Function add number. A is going to be a number. B parameter is going to be a number. And I'm going to get a number in return and return A plus B. Simple, right? Then I'm going to write another function. Function add strings. Add strings, and it is going to take 2 parameters again. A is going to be string, B is going to be string, and in return I'm going to get a string, and return is going to be A plus B. So they looks the same. The number add numbers function returns the sum of two numbers, and the add strings, it returns this function returns the concatenation of two strings. So it's possible to use a union type to define a range of types for function parameter and its results. So we can just write function. Instead of writing this, you can just write function add, and then A is going to be a number or string, and B is going to be a number or string, and return is going to be a number or string. Now I can just write if type of A equal to number and type of there is no space, type of B equals to number, then return A plus B. Now we can write something like this: A is equal to string and B is equal to string, then return A plus B. However, this union type doesn't express the relationship between the parameter types and results accurately. So you can see that here it is showing me some error. Function lacks ending return statement and undefined. So it should be ending return statement or something. The add function tells the compiler that it will accept either number or string and return a number or string. If it fails to describe that the function returns a number, when the parameters are number, and returns a string if the parameters are string. So to better describe the relationship between the types used by a function, TypeScript supports function overloading. For example, let me comment them out. For example, we can say function add a is going to be a number, b parameter is going to be a number, and it is going to return a number. Then function add a is going to be a string, b is going to be a string, and then it is going to return a string. And then function add a is going to be any, b is going to be any, and the return type is going to be any, and return a plus b. In this example, we added two overloads to the add function. The first overload tells the compiler that when the arguments are number, then add function should return a number. The second overload does the same for a string. Now, each function overload defines a combination of types supported by the add function. It describes the mapping between the parameter and the result they return. Now, when you call the add function, the code editor suggests that there is an overload function available. So let's see that in action. Let result equals add 10 plus 20. Result. So it is giving me 30 without any issue. It is telling that function A number, function B, and there is an overload. Now instead of 10, if I write hello and world, it is giving me hello world. So let's summarize what is happening here. I have defined three function signatures, add function. The first signature expects two parameter number and returns a number. The second one expects two parameter string and returns a string. The third signature serves as the implementation signature. It accepts parameter of any type and returns a value of any. So when you call the add hello world, TypeScript infers the type of the argument as the string because it matches the second function signature. So it matches the second function signature. Therefore, it executes the second overload of the add function, which concatenates two strings, resulting in hello world. Now let's see how we can use function overloading with optional parameters. So let's modify this. Function A is going to be a number. Let's just say function sum. A is going to be a number, B is going to be a number, and it will return a number. Then function sum. A is going to be a number, B is going to be a number, and C is going to be a number, and it will return a number. And then say sum. A is going to be a number, B is going to be a number, C is going to be optional, it is going to be a number, and then return a number. If C return A plus B plus C, otherwise return A plus B. So what are we doing here? The first two lines decides the function signature for two different versions of some function. The first signature expects two parameters, A and B, of type number and returns a number. The second signature expects three parameters, A, B, C, of type number and returns a number. Now, the last one is the implementation signature. The third line provides the implementation for sum. a function, it accepts two required parameter a, b, and both of types number and an optional parameter c of type number. Inside the implementation, it checks if c is provided. If c is provided, then it's not, and if it is not undefined, it adds all three parameters and returns the sum. If C is not provided, then it returns the A plus B. So this pattern of overloading function signature allows us to define multiple ways to call the same function while maintaining type safety and clarity in our code. In this case, we can either call some with two arguments or some with three arguments. So let's see that the result, see the result. Let result is going to be sum 3, 5, and then console log result. Let's see what the output is. Output is 8. Now, I'm going to use the same function result 2, and I'm going to say sum, and in this case I'm going to give it three parameters and console log result 2, result 2, result 2. In this case, I can see that 8 and 15 both are there. So by overloading the function signature, we can have different behaviors for the same function name depending on the number of arguments provided, and this allows us to for greater flexibility and clarity in our code. In this lesson, we are going to learn about TypeScript class. JavaScript does not have a concept of class like other programming languages such as Java or C Sharp. In ES5, you can use a constructor function and prototype inheritance to create a class. So let's see how we can do that. So first we are going to write a function and then person and then SSN and then first name and then it is going to be last name. This dot SSN is going to be SSN and then this dot first name is going to be first name and then this dot last name is going to be last name. So we did not mention any types here. Now, next, you can define a prototype method to get the full name of the person by concatenating first name and the last name. So we can use person dot prototype dot get full name, and we are going to add a function. This function is going to say, okay, return this dot first name and then this dot last name. Now you can use the person class by creating a new object. Let person equals new person, and then it is going to be SSN is going to be 171. SSN means social security number 28, then 0. So this is it. And then I can write the first name, John, and then the last name is going to be Sina. And then if I console log person dot get full name and then call it, I'm going to get undefined John Cena. So why is it undefined? So I'm getting undefined because it is going to be equal. Now it is showing me that the first name and the last name. Now in year 6, I can define a class that's simply uh, a syntactic sugar for creating a constructor function and prototype inheritance. So let's write this in ES6. Instead of function, I'm going to write class, and then is going to be, it will be inside this, and then I'm going to write a constructor here, constructor, constructor, SSN, first name, first name. Let me remove them. It is going to be like this, SSN, then first name, then it will be last name. Then the constructor will take first name, last name, and this dot SSN is going to be SSN. This dot first name is going to be first name, and this dot last name will be last name. And I can use the method as well here. To get the method, I can say get full name, and then inside this, I'm going to write return, remove this. Now, if I console log it, I can see the exactly same thing. John, Randy, Orton. I can see that it is showing me the exactly same thing. Now we can add type annotation to the properties and methods of the class. So let's see how we can add the type annotation. Here it is showing the error parameter as set implicit has any type. So I'm going to give it a type of string. This is a type of string, and this is also a type of string. So it is showing the same thing. Nothing is changing. So this is how we can use um, the types in our classes. Now here we can also use another type. We can just say that it is going to return the string. So this is how we can use the class. We can use TypeScript in classes. Now let's learn about access modifier. TypeScript provides three access modifiers to class properties and methods: private, protected, and public. The public modifier allows access within the same class. The protected allows access within the same class and subclass, and the public modifier allows access from any location. So let's have a look at them in code. So here I have the person, then I have my SSN first name, last name, and the types and everything. Now, if I make it private with the private keyword, private, now, and if I just say it is going to be a string, it is going to be a string, and it also is going to be a string. Now I have everything. Now, if I want to see my result, console log, I want to access this SSN property. So person dot SSN. It is throwing a runtime error. Its property SSN is private and only accessible within the class person. So it is throwing me an error. Property SSN is private and only accessible within the class person. If I look at the TSC compile error, you can see that here found one error watching and it is showing the error. Property SSN is private and only accessible within the same class person. Now let's learn about the public modifier. The public modifier allows class properties and methods to be accessible from all locations. If you don't specify any access modifier for properties and methods, they will take the public modifier by default. For example, this get full name method of the person class has the public modifier. The it explicitly adds the public modifier to the get full name method. So if I say public, so I can access it from anywhere. It is not going to be an issue. Now let's come to the protected modifier. The protected modifier allows properties and methods of a class to be accessible within the same class and within subclass. When a class inherits from another class, it is subclass of the parent's class. The TypeScript compiler will issue an error if you attempt to access the protected properties or methods from anywhere else. To add the protected modifier to a property or a method, you can use the protected keywords. For example, instead of private, you can just write protected. Now let's see that protected as an with example with the subclasses. This is the string, this is the protected route. Now I'm going to take another class and I'm going to say class employee extends person, and then private. I'm going to say private employee ID is going to be number, and the constructor is going to be SSN. I can access the SSN from here. String first name, last name, and employee ID is going to be number. And then I'm going to use the parent SSN, first name, then last name. This dot employee ID is going to be employee ID. Now, if let's remove this. Now I have created a new object, person, and I'm going to create another object, employee with the employee class. I'm going to give the SSN 111, 222, 333, and I'm going to give name John, Sena, and I'm going to give the employee ID 1234. Now, if I console log it, um, person dot get full name, I can see the full name is Randy Orton. Now, if write employee dot get full name, it is going to be John Cena. And if I write employee, if I write, let's just say person dot ssn, then it will show an error. The error is property SSN is protected and only accessible with the class person and its subclass. So this subclass can access the SSN, but anything else will not be able to access this. Now, if I write employee.ssn, same thing, because protected only accessible within the class and its subclass. This subclass can access this SSN, but if you try to write it anywhere else, it is not going to show. It is not going to, it will show an error. So this is how you can use the protected keyword. Now let's learn about read-only modifier. TypeScript provides the read-only modifier that allows you to mark the properties of a class immutable. Means that you cannot change it. The assignment to a read-only property can only occur in one of the two places, in the property declaration or in the constructor of the same class. Let's see this in code. Now let me remove this console. Let me remove this. And now instead of protected, let's just say this is going to be read only. Now what will happen if we make it read only? Let's console log it, console log person. Let's see what it shows me. So it is giving me the object. Now, if I write person dot SSN, what will it show me? It is showing me the SSN number. Now, if I want to change it, person, let's not use read only. Let's change it person dot SSN and write 1234, this number, and put it here. Then you can see the SSN number has changed, right? SSN was this number, but whenever I changed it, it changed. Now, if I write read only, and you see that there is an error here. It says that cannot assign to SSN because it is a read only property. So it is not changing, it will not change anything. It will throw an error. Is so the read only function, it says that okay, you can read things, but you cannot change anything. If you try to change anything, I'll throw an error. So this is the error. It is showing that cannot assign to a SSN because it is a read only property. Now let's learn static properties. Static properties in TypeScript belong to the class itself rather than the instance of the class. They are accessed using the class name rather than through an instance. So let's see how it works. I'm going to um, write static keyword, static, and then I'm going to say number of person, and I'm going to say it is going to be of type number and it will be equal to 0. Okay. And then I'm going to use this person dot number of person and plus plus. So keep this in mind that it belongs to the class itself rather than the instance of the class. And they are accessed using the class name rather than through the instances. So you writing this is not going to work. It is going to throw an error. Property number of person does not exist on type person. Did you mean to access the static member person dot number instead? So it can be only accessed within the class. Now, if I create 3 instances, let's just say, let me comment them out also. 1, 2, 3. Person 1, person 2, person 3. So I have created 3 instances, and if I console log person dot number of person, let's see what it shows me. It is showing me 3. So in this example, the number of person is declared as a static property of the person class. It is incremented inside the constructor every time a person instance is created. You can access this static person directly on the class itself by writing person dot number of person rather than through the instance of the class. If you want to write, let's just say, person one dot number of person, it is not going to show. It will say that property number of persons does not exist on person. Did you mean to access the static member this instead? So this. So it allows us to keep track of global state or perform actions that are related to the class as a whole rather than the individual instance. So if you want to keep track of something such as how many instances you have created and you want to do the calculation in your class rather than with the instance, you can use this static method. Now let's learn about TypeScript interfaces. TypeScript interfaces define the contracts within your code. They also provide explicit names for type checking. So let's write a function first. Function get full name, and it's going to be a person. And here I'm going to pass an object. I'm going to say first name. First name is going to be string. Then the second name is going to be a string. And I'm going to return person dot first name and then person dot last name or the second name. And then I'm going to say let person John, second name is going to be Sina. Now if I console log the get full name, console log get full name, yes, get full name, then I pass this object as the argument. Let's see what I get in console. So in console I get John Cena. But you can clearly see from this code that the type annotation of the function argument makes the code very difficult to read. Now if you have 100 parameters, then what are you going to do? Are you going to write like this? No, it's not going to be a feasible thing. So to solve this issue, we use interface. So interface, interface, it is convention that we write the interface in capital letter. The first word is, the first letter is going to be in uppercase, and just I'm going to cut it. I'm going to remove this object, and then I'm going to just paste it here. And this interface is, we can say, it is like a type, and we can just use it here. In person, if I put here that person, then everything is same. Now the code is very easier to read than before. If I just take it and put it here, then you can see the code is very concise, and you can just add properties, key values, anything that you like here. You don't have to rewrite them, and you can also reuse them in another function as well. And there are things, let's just say, um, you don't want all the properties. Let's say second name, instead of second name, I'm going to say middle name, and this person is going to be this type as well. I'm going to say middle name, so it is not going to be second name, it is going to be middle name. And last name is going to be also string, and here it is crying for the last name. Last name is going to be um, Jamal. So here it is going to be last name, or maybe the mid last name. Okay. Now, as you can see from here, we might not always have the middle name. Some people has just only the first name and the last name. We may not have the middle name. Now, if I don't put the middle name here, it is throwing me an error. It says that property middle name is missing in type something, middle name is declared here. So we must put it here. But we don't want to. Sometimes the first name and last name is going to be there, not the middle name. So we need optional properties. And to do that, we just use a question mark here. Question mark says that this property is optional. So if I remove the middle name, see, no error. I'm getting all the things. I'm getting John Jamal. I'm not getting the middle name error. And if I put the middle name, then I'm going to say middle name. And if I remove it, no issue. Now we can also use some read-only properties. Read-only properties mean that you can read the property, but you cannot change anything. So let's add another thing here. I'm going to say email, and this is going to be email at gmail.com. Oh, sorry, this is going to be string, and it will be, see, it is throwing me an error already. So it will be email, it will be a string, email at the rate gmail.com, and here there will be a comma, and I'm going to say that email is person.email. Now let's see email. Okay. So this is the email. Now, if I want to change this email, what are we going to do? I can just write person.email, then changed email at gmail.com. Now let's see what happens. Now you see the email name has changed to changed email.gmail.com. But we don't want to change it. We want this thing to be static. People should not be allowed to change it. So to solve this issue, I can just add a property, add a keyword read only. Now, if you look here, it is going to say that cannot assign to email because it is a read only property. So you cannot change it. You are seeing this because it has been compiled, but it is going to throw you an error here. It is going to say that email because it is only a read only property. You are not going to, you will not be able to change this thing. We can also write function types with interfaces as well. So let me comment them out. And for function, let's just say I want to create an interface for a function, what the function is going to look like or what will be its type. So interface, and then the function name. Let's just say um, function format. And then it is going to take a parameter. Parameter is going to be string, and then it will take an another parameter. It is going to be a boolean, and it is going to return something, and it will be a string. So this is the function. The function is, will take two parameters, one string, another one boolean, and it will return a string. Now let's just define the function format, and then we are going to say that string is upper is going to be boolean, and then it will return string, and then it will return is upper than string dot to lowercase, and if it is lower than a string dot to uppercase. So this is what is going to happen. Now if I want to give a format to it or the type to it, all I can say is that function format. Let's do it like this. Let format going to be function format. Okay, now everything is all right. So I have taken an interface, and given this interface, I have assigned this format, this type to this format, and this format will hold a function that is going to take a string, an uppercase, and something. Now, if I want to say console log format call call this and say hi. And the second value is going to be true. Let's see what I get in console. I'm getting hi. So it is changing. If I say it false, then I'm getting hi. Then it is changing it to uppercase. Instead of a string, if I try to give it a 23, now it is throwing me an error. It is saying that argument of type number is not assignable to parameter of type string. So our type is working. Our type is working. Now it is showing me 23. So this is how we can use the interface in function as well. Now let's talk about uh, extending interfaces in TypeScript. So in TypeScript, extending interfaces allows us to create new interfaces based on existing ones, inheriting their properties, while optionally adding new ones or overriding existing ones. So let's see that in code. So first thing, we're going to define the base interface. We're going to say interface, then shape, then we're going to say color is going to be a string. And then we can extend the base interface. So we can write interface square extends shape. Here it is going to say side length. It is going to be number. Now let's implement this. Let square, and the type is going to be square. And then color is, let's not write any color. Let's say side length 10. Now you see it is throwing us an error. In this interface square, we have only one property, side length, right? So we have given the side length and it is numbered. So what's the problem? Block scope variable implicitly binding has any type. So I don't think that is the issue. If I just write color and give a blue, let's see what will happen. So let's just give it another 2, 2. Yeah, the problem I think it is I did not give any equal sign. So now if I remove this, it is saying that property color is missing in type. So it does not have, the square interface does not have the color property, but still it is saying that, okay, you're missing this color. Why? Because when we extended it, square extends shape, so it also took the property of shape as well. So this one we can say that square plus shape, this two is equal here. So if I write just color and say red, then everyone is happy. Everyone is happy. So this is how we can extend the interfaces. And there is also another thing we can do with interfaces. We can also add multiple interfaces together. So let's have a look here. Here we are giving shape string. Then let's add another interface. And here we are going to say interface dimension. And it is going to be width is going to be number and height is going to be number. And interface, instead of square, I'm going to say rectangle. Rectangle extends shape and dimension. So here it means rectangle e- equals, let's just say, yeah, rectangle equals rectangle plus shape plus dimension. So these three things are added together here in this. So now if I want to say rectangle equals rectangle, now I need to add these two as well. If I add them, number is equal to 10 and 19, 20. Now everything is gone. Everything is perfect. So we can see that we can extend to multiple interfaces as well. In this lesson, we're going to learn some advanced type concepts. So first thing, TypeScript in intersection types. An intersection type creates a new type by combining multiple existing types. The new type has all feature of the existing type. So this is the new type and it will combine type A and type B. Let's code them. Suppose I want to take a type. It is going to be person and name is going to be string. Age is going to be number. Type employee is going to be job title. It is going to be string. And salary is going to be number. Now I'm going to create another type and it is going to be called person employee. Now the type is going to be person and employee. So I use the and sign to add both job title, salary, and this name, this type. Now, person employee is a type that has all the properties of both person and employee. So if I write Randy Orton and say that person employee, what should I add here? I should add name. So age is missing here. It is saying, okay, still I'm getting an error. Why? Because employee and job title and salary is missing here. Job title, salary 50. Now, if I console log it, I can see my object here. So this is how I can use the intersection to add two types together and create a new type. Now, what is the difference between this insertion type, intersection type, and the union type? The union type uses this symbol, and it means that this type either is going to hold this or it is going to hold this. Now, if I remove these two, no error. But if I remove this, then it is giving me error. So it means that in union, it is going to be either this type or this type, but in intersection, it has to have both of the types. And there is one thing to remember here, the type order does not matter. If you write the job title in the beginning is fine. I mean, the order here does not matter. As long as the information is there, you are good to go. Now, typecasting. JavaScript doesn't have a concept of typecasting because variables have dynamic types. However, every variable in TypeScript has a type. Typecasting allows you to convert a variable from one type to another. In TypeScript, you can use the as keyword. As is going to be as. You can use the as keyword or the greater than less than equal operator for typecasting. So how do we change a type in JavaScript? Let me comment this out. And in JavaScript, we just say let my var equals to any and 1, 2, 3. So we're telling TypeScript, okay, my var is going to be from of any type, and whatever you get, you are going to send my number. It is going to be a number, and you change it. Parse int, percent. I'm changing the integer to my var to an integer. Now, if I console log my number, it is 1, 2, 3. It is showing me as a number. So I have converted the string to a number. Now, this is the simple case of typecasting where we are converting a string to a number. But in TypeScript, explicit typecasting can also be done using the as keyword. For example, my var, any, let's just say this is hello. And if I consider my number, then I write my var as number, my var as number, and console log my number, I can see that it is not coming as a string. Now, if I write a type of, and my number is going to be shown as string. Now, why is that? So in this code, I'm essentially telling the TypeScript that, hey, I know my var is of type any, but trust me, I want to treat it as a number. However, TypeScript doesn't enforce this at runtime. It is up to us to ensure that the my var actually holds a value that can be safely treated as a number. In this case, my var is a string and TypeScript doesn't do any runtime conversion. So even I'm passing my var as a number, it is still a string at runtime. So if I want to convert it to a number, I should use it function like parse int or parse float. So after doing that, then my number will truly be a number type. So if you want to treat something as a number, and tell the TypeScript, okay, I want to treat it as a number or any other value, any other type, then you say as number. But it is not going to change the hello to a number. It is going to be a string. Now we can use the typecasting in another by using this operator as well. And to do that, I can just write hello 1, 2, 3. It is going to be any. And then I'm going to say it's going to be a number and my var. Now you see that it is still treating as a string because it is not actually converting, but TypeScript will treat it as a number. In this lesson, we are going to learn about TypeScript generics. TypeScript generics allow you to write reusable and generalized forms of function, classes, and interfaces. So let's see them in action. Now we are going to write a function first. Function get random number element, and it is going to take a parameter. It is going to be an array of numbers, and then it will return me a number, and inside that it is going to take a random index mat dot floor mat.random, then multiplied by items.length. And then I'm going to return items random index. So I want the random index from an array. So first thing, find the random index, get the random element based on the random index. To find the random index of an array, we use the math.random, and then that returns a random number between 0 and 1. It is then multiplied by the length of the array and applied the math.floor on the result. So if we want to use it, we can write let numbers, and it is going to be 1 5 7 4 2 9, and console log get random number element and pass in the number. Let's see what it shows us. It is giving us a random number 1. Similarly, we can write another function. So copy this, and it is going to be random string element. Instead of number, it is going to be string. String element items, it is going to be string. Then it will return me a string. Random index will be the same. Items will be the same. And here it is going to be colors. Green, and I'm going to pass in the colors. So it is giving me a random color red, and this one is giving me a random number 4. There is a problem with this. You can see that this, why is it showing? It is compilation error, I think, because it is not number. Oh, the problem is I did not change it to this. It is going to be random colors. So now everything is fine. Now the logic of the get string element function is the same as one as the get random element function. They're basically the same thing. They're the same. Now this example shows how to use the get random function, get random elements. Now, if we want to find something, maybe we would want to find something, a random key from an object. Now that becomes difficult. Then we would have to write another function that looks like the same. Just because the types are different, we will have to write another function. So this does not solve our problem. To do this, we can just write another function get random element, and then t. I'm going to explain this t, and then item, then t, then return t. Then it is going to be let random index. It's going to be math.floor math math.random, and then multiplied by items dot length, and return item, then random index. Now this function uses type variable t. The t allows us to capture the type that is provided, at the time of calling the function. Also, the function uses the t type variable as its return type. Now, this get element function is generic because it can work with any data type, including string, number, objects. By convention, we use the letter t as the type variable. However, you can use any letter that you like. Now, let's use that. Let numbers is going to be 1, 5, 7, 4, 2, 9, and let random element, then it is going to be random element, and inside that I'm going to put t number, and then I'm going to say numbers. And then if I console log a random element, I can see it is giving me a random number. Now if I write type of, the type of this is number. Now instead of numbers, if I just give them colors, red, green, then yellow, and I give it, say it is a string, and give it string. Now the random element, type of random element has become a string, and it is giving me a random color, and the type has converted to a string. Now this is how we can use the generic type in TypeScript. Now here it explicitly passes the string as the t type into the get random element function. In practice, we will use type inference for this type of argument. It means that I will let the TypeScript compiler set the value of t automatically based on the type of argument that I passed into it. So if I remove this and see, now still it is inferring that whatever I am passing here, it is a string. So the value of t has changed to a string. Now if I give it a number, if I give it numbers, then the type has automatically changed to number and the value has changed to 4. We can use the generic function with multiple types. Let me comment this. It means that we can use multiple types and combine them. For example, let's just say function merge, and then we'll take two types, u and v. And this function will take two parameters, object1, it has the type of u, and object2, it has the type of v, and then it is going to return destructured object1, comma destructured object2 combined. This is what it is going to return. Now this merge function merges two objects with the type u and v. It combines the properties of the two objects into a single object, and this type inference infers the return value of the merge function as an intersection type of u and v, which is u and v. So whatever it returns, the type is going to be return type is going to be u and v. It is going to TypeScript is going to infer that. So both of the properties should be there. Now let's use that. Let result equal to merge this function, and I'm passing two objects, name John, and another object, comma another object, it is going to be job title, it is going to be wrestler, or ESTN wrestler. Now I'm going to console log the result. Let's see. See, these two has been combined into one object with the name John and job title, job title wrestler here. So what is the benefit of TypeScript generic? It leverages type checks at the compile time. Then it eliminates typecasting. We don't have to write as number, as string or anything. Then it allows us to implement generic algorithms. So in summary, we can use TypeScript generic to develop reusable, generalized, and type-safe function interfaces and classes. Now let's learn about generic constraint in TypeScript. Let's take this function. This merge function expects two arguments, two objects. However, it does not prevent us from passing a non-object like non-object. So if I, instead of job title, if I say that 25, then it is not giving me any error. It is not giving me any error because it is taking a generic type. It is taking a generic type. We are not telling it anything. So it is not taking any error. And I don't know why it is not showing anything. Oh, okay, it is here. So name is equal to John, and I can pass, instead of an object, I can pass just a number, random number, and it is not telling me, it is not giving me any error. So instead of working with all types, we may want to add a constraint to the merge function so that it works with objects only. To do this, we need to list out the requirements as a constraint on what U and V types can be. In order to denote the constraint, we need to use the extend keyword. For example, if I write U extends object and V extends object. So now it is showing us an error. Extends object means that, okay, you may take whatever you like, but it has to have characteristic of an object. Now let's see what it says as argument of type number is not assignable to parameter type of object. So now we must use object here. If we use job title, now we can see that our problem has been solved.